Hello everybody. In this video, I'll talk about vector search and why vector search is not enough from enterprise's standpoint. Okay. I'll mainly talk about 3 points: RAG, what exactly it is, what are the limitations, and how those current the problem being solved in the current scenario. Then I'll talk about the enterprises, why POCs are failing. It's been a couple of years now since enterprises have been, trying to create a first expertise, a group of resources to focus on agentic products, and now trying to use different technology, different products to solve that problem. And the third one is I'll talk about a new paradigm called a VQL. It's more like a sequel for unstructured data, deterministic, not probabilistic. Exactly the problem we are solving using this VQL, which are there in the RAG framework. So let's move on to the RAG workflow. Now, RAG workflow, you're chunking, you're embedding, retrieval. All these are touch points, where you have different type of errors. This is a very nice paper, the link on the right hand side top of it, the archive link, where this paper talks about different touch point where error takes place, which introduces, issue in the retrieval, right? So you have chunking, multiple kind of errors are there, under chunking, over chunking, context mismatch, lot of overhead you cannot measure. Then you have embedding dilemma, whether to use a 384 dimension embedding or a 1.5K dimension embedding, because there are a lot of consequence also what embedding you choose on cost and quality. Then you have retrieval. Retrieval is basically the vector databases of the world. The misretrieval, low relevance, semantic drift. Then there's an issue with the algorithm which all the vector database use, mainly the ANN, which is approximate. It provides the approximate outcome. It doesn't tell you the deterministic outcome, and that is one of the biggest reason. The output which comes to the re-rank at the next stage is actually have a very low recall and low precision. And for use case which are business critical, you cannot have that situation. So you need everything full corpus. You need a deterministic outcome like SQL in structured data. Okay, next re-ranking. Now, since the outcome provided by the systems have low recall and precision, the re-ranker is used to rank it again. But re-ranker is not that great of a help, especially the way the LLMs are being evolving, because the outcome itself is of low recall and low precision. If you rank it again, it's not going to add much of a value. At the same time, the re-ranking is very expensive. You're using LLMs to do that again, right? Then you have a generator. Generator are basically LLMs. We'll not talk about generator because this discussion is this video is more about the retrieval part of it, the importance of retrieval, and how hallucination can be controlled if the retrieval is deterministic. I'll quickly move on to the next part. So I was talking about the whole workflow here. So what I'm going to talk about is chunking first, right? In this slide, we started with chunking. So in chunking, there are three kind of chunking. There are actually 4 or 5 kind of chunking are also there. I think people are trying to use LLMs to chunk the data. Not a scalable way right now, but still that is another approach which people are using. But these are the major type of chunking that people are using. The fixed overlapping semantic. Now here, if you see, even with the fixed overlapping semantic, the context issue is still there. So in chunking, for example, I have 3 reports. I have reports of John Doe, a cardiology report, John Doe lab result, and John Smith radiology result. Now when you chunk it in the RAG framework, you have different chunks, all the 6 chunks. Now the query is, please provide health marker of John Doe. Now the way the similarity search works, the semantic search work, similarity, you actually create this place provide health marker into a vector. At the same time, all different chunks are converted into a vector. You match the similarity, you get a similar score. Now the thing is, in this statement, please check provide health marker of John Doe. All the words here are relevant to all the reports, just barring this Doe, right? John Doe, you have John Smith and John Doe and John Smith. Now the problem here is the similarity in this case would be very high in all the cases. And that is the reason you see the final selected chunks, 2 are relevant and irrelevant, right? The calcium deposits notes in liver. Now, this kind of use case, the medical use case, you cannot afford to be wrong, right? Now, if you're providing this wrong information to LLM, obviously the outcome would also be incorrect. And in the current setup, these kind of things would still work in case of chat-based use cases, which actually is happening. But in case of these kind of, more of a, I would say, business critical use cases, it's very difficult for you to get a very deterministic sort of answer. That's what happens with chunking. So after chunking, they call it embedding. Like I talked about embedding earlier. Embedding could be 384K dimension, 1.5K, 1000. The consequence of selecting embedding is the latency and accuracy. At the same time, which embedder to use? Yeah, they have different embedder customized for different domains, so it's again an overhead. Now chunking, then embedding, it's all a lot of people, a lot of team actually work in that area, try to spend a lot of time, but the measurability is a big pain, a big problem there. So this is a very simplified implementation project structure. So you have to create a data pipeline, pre-processing, chunking, experimentation, lot of overhead, embedding, experimentation, lot of overhead. So that's how the typical, I would say, a very simplified structure of a project looks like for that. Now, till now, how industry is solving this problem, right? The search problem I talked about, not getting the right context in the from the vector database. People are trying to use hybrid search. Now, this is interesting. Now, in hybrid search, what happens is the vector database is okay. Along with the vector, let me also store some metadata with the key value pair, right? So, which this actually means you have to convert the data, the unstructured data, especially on the left hand side, into a structured data. Now, on the left hand side, that structured data is variable. Okay, maybe in some cases it could not be variable. I don't know which cases those are, but there has to be some cases, simpler use cases. But in most of the use cases, let it be HR resume search, or let it be these medical reports, things would vary, right? It's very difficult to create a standard structure to create these tags. Now, how it happens is once they convert into this structure, which is again is a big overhead, maintaining the schema. Now, if there's a drift in the data, some new feature comes in, you have to do it again, rebuild again for the old data as well, which is a big pain. Especially at scale, it's not even feasible. However, this is the only option people have, so they do it. They create the metadata. A lot of people even use Elasticsearch for that matter as well. But again, the same problem. You have to convert into a semi-structured format. Here you have documentation type, so it's very difficult to maintain, like I'm saying. Now what happens is the vector database have the embeddings. They also have this metadata. So when you shoot a query, you write a filter there, okay, where the document type is like API documentation. So it'll filter out that data and then do the semantic search and give you an answer, right? But like I said, the scaling is very difficult using this way. But yes, this is what people do, the hybrid filtering. Hybrid filtering, you have Elasticsearch, like I talked about, Pinecone, or any vector database, you create those pipeline, and this is how the structure looks like. Now, the important part, I told you in the first couple of slides, the core reason why the quality is poor is mainly due to retrieval, because the kind of algorithm which are used. Let me walk through this slide first. You can do a full search as well, but engineering perspective, that's not something which is feasible right now. People often try to you use techniques like quantization, reduce the vector sizes, all those things people do, but again, it's approximate. Now, both are probabilistic algorithm, okay, like I said, based on approximate nearest neighbor. Now, on the left hand side, if you see the query, the green dot, when you ask a query in this format, you actually look for a content similar to that query. If you see the two red dots attaching, it actually looks, take all the connected green dots along with that. However, if you see on the left hand side as well, there are another dots which are closer to this centroids. So basically what I'm trying to say is there is huge possibility that a relevant chunk is missed here because you're not even looking at all the data here. So what people do is, like, if you can say n probe, so n probe is only look at two nodes. Now, if there's another node nearby, it won't look at it, right? So all the data is missed, and that is the reason the recall is pretty poor. If you look at the current using ANN approach. On the right hand side also, if you see, all the gray one are the selected ones. You ask a query, and all the gray dots are the selected one. But again, the blue dots are also near the gray dots. They're also relevant to the query. They're also missed. So people say in graphs it's very easy, it's very accurate, but the issue still remains of the completeness, the coverage at the same time. Now, the sixth limitation you see, let's talk about the graph, because graph is something where the industry is trying to again go. There was a time during big data where Neo4j, the different graph database comes in. Enterprises burn their finger and then moved away from it because the maintenance is very, very expensive here. Now, specific to HNSW, the limitation one is the graph size grows rapidly. The memory it takes is huge if you keep scaling it up. At the same time, updates and deletes are very expensive in this graph. Long range relationship are very hard to represent because if you have big documents, one intent could be somewhere, one intent could be stored somewhere else, right? It's very difficult to connect those. Again, the recall sensitivity to parameters. So while you create a graph, you have configuration parameters. When you search, you have a configuration parameter. Lot of parameters, lot of overhead. There's no standardization there, okay? And you have to keep tuning it. Even for a single database, even for a single same type of data, let's say healthcare, you might configure it once, but again it might change again, right? Because the accuracy, the retrieval quality will drop, right? Similarly, for a large document use case, multi-hop knowledge, it's very difficult for you to maintain those relationship, in graph. So that's about graph. The next So this is how the project structure looks like. Now, from an enterprise point of view, let's say you have a vector database. These are the different steps. You have upload document chunk. I walked through, all of these points in the earlier slides. You see the challenge, the key limitation, and the ownership is from enterprise perspective. Now, any customer doesn't want to get outcome in a millisecond and a wrong outcome or a half correct outcome. Nobody wants that. You would rather spend 2 seconds, 3 seconds and get a right outcome. That's very important. At the same time, the deterministic accuracy is non-negotiable. With many proof of concepts succeed in the lab, they fail in the real world deployment, primarily because of accuracy. Right? Business want deterministic outcome, they don't want a probabilistic outcome. Now, so what at Agent Analytics for the last couple of years, what we have come up with, this paradigm of VQL. It's basically, like I said, the semantic SQL for unstructured data. Now, why will we need VQL? So we cannot solve real world problem with approximation, and the poor result, result in hallucination. So we need to be deterministic in nature, and that exactly we have, started talking about this VQL, and I'll show a demo as well. What exactly it is. Okay, so what is VQL? A query language that combines semantic understanding with logical precision, enabling SQL-like operations. Now, I noticed this problem while orchestrating agents. A lot of time, an agent needs the information from a database, and what agent do is agent use LLMs use extract the parameter and do a tool calling. A lot of time it fails, a lot of time it works. Again, it's probabilistic. But if we can enable this exercise and make this retrieval deterministic, agent will give you correct outcome. The dependency of retrieval will go away. Now, that's exactly what we did. So how it works is, so you can just upload the data, Waveflow DB. You don't need to worry about schema. There is no AI pipeline. There is no complex implementation. All the project structure which I showed you, you don't have to do any of it. Data, upload the data. We have done innovation across engineering and algorithm, which actually help us achieve this. Now, for example, you want to ask a query about clinical trials. So you'll write a query like a clinical trials or observational studies on type 2 diabetes in India. Now, what our engine will do is engine will extract clinical trials, observational studies, type 2 diabetes, merge it with the semantic search, and then give you the final outcome. So you have a control over the what type of outcome you're getting. Okay. So that's a database, or you can call it a namespace. Okay. It's a data about health and wellness articles. Okay. Let's say, for example, so it's a syntax. Okay. I will select top 30. Okay. Where query is do we have what benefits? Let me add what benefits are there in Earl Grey tea. Okay, let's say this is the query asking, and all the filters I want to apply, I can just put in. I want to write Earl. Let's say that. So here, what I'm trying to do here is I'm trying to ensure the data contains Earl. Okay, or let's say Earl. Let me write Earl Grey tea itself, just like in SQL. Okay. And when you see, I ask for top 30 results. I get first result because this is the only document which contains Earl Grey tea. You can see the score. This basically means it's semantically also it's at the top. At the same time, it contains all these filtered keywords I have mentioned here. So say Earl Grey tea, all the information is there. Now this database also contain resume information, but like I said, it doesn't matter because we have the control over the retrieval. We can do this. Now, let's say I want to ask more question about the tea as well. Let me remove this filter. Okay. because it's not mandatory. Let me see if I can just simply run it. Okay, so I get all the Earl Grey tea and all those things. Let's talk about talk about the keto benefits. Let me ask some other question. What are the bene- benefits, benefits of keto diet? Okay. Like I said, I have filters so I can write keto. See, the important part is I did not create any JSON here. Okay, I don't need any JSON here to convert the structured data into unstructured data, and then keep working around it. So you see here the keto diet is there. The document comes in, 24 food to eat on keto diet, all the relevant documents. Now, for example, if I see this Mediterranean can lead to weight gain. Okay, let me ask. Okay, this is interesting. So I can put multiple filters, keto or let's say weight gain. It will specifically filter out a document first which contains keto and or weight gain. Okay, so it's an or condition we have. We can put and condition as well. It's up to us how we're going to design the whole problem. Okay, so let me see. Now if I run it, I should ideally get keto diet. Yeah, I got the same document, right? The keto. Similarly, if I want to make it more deterministic, I want to specifically focus on coffees, my query. So this contains could be a parameter. For example, if you're solving a medical use case and you have a user ID there, you can put a user ID here. So it will only look at that data. You don't need to do any sort of schema change, conversion from structured to semi-structured JSON format. For example, make your coffee healthy. So I can put it like healthy, coffee healthy. Okay. And yes, see what makes a coffee healthy. That gives a deterministic nature. Now the important one more thing what we do is we three tiering. Okay, the first tiering where you see 199.5, it basically are the result which are semantically also correct, and from a keyword perspective they're also at the top. So it's a very strong result which you get based upon the filters we have. So this thing makes it deterministic. The second category is 127. So this category is basically which are not semantically in the top, but they contains all the keywords there, right? And the third category is this score here. This score itself is very good, right? But again, so the third is the semantic. If none of the rules are it's satisfied, then it simply look at the semantic result. Now please note semantic result what Wave4DB provides are full corpus. We don't use ANN. We have done innovation engineering as well, which actually help us do a full corpus search, because of which our output is very accurate, and that's exactly what we need for agentic system. Now going back to the slides, this is what we have, and I give another example. Okay, how this filters actually helps you get a deterministic sort of result. For example, the query is which tractor has the best PTO of sugarcane farming. Now PTO farming as something, I can the tractor ID, I can use it and get a exact model specification details. But if I'm using this semantic search, it might confuse with 5410. I might get a result from different type of tractor specification, and that exactly is the problem there in the current framework. The outcomes are only semantic, they're not intelligent. So you have to make them intelligent, make the coverage complete, so that whatever the outcome goes, the agents are determined. So thanks a lot for watching this video. Do let me know if you need a more in-depth explanation of different touch points I discussed in RAG workflow. At the same time, you can contact us at these email IDs. I will post that in comments as well. Thanks a lot. It was nice being part of this video.